here. In the XY coordinate plane, well, a different beginning formula. Is point P equidistant from points, well, these 2 points? Is point P equidistant? That is the distance between P and this point the same as the distance between P and this point? That's the meaning, right? And they tell you in one statement, the vertical coordinate of point P, and in the second, the horizontal coordinate of point P. Here, this is an interesting question because just from finishing reading the question, one person, who considers themselves very logical would say, oh, but just one coordinate won't help me establish the true distance between a point and another. So if I take the two statements together, now I have the exact position of point P. Therefore, I can establish whether the distance between that point P and the given points in the question is actually the same or not. No matter what that distance will be, I always have a definitive answer from taking the two statements together. So the correct answer must be C. But is that the case? Take your time to analyze this one. Okay, people. What they're actually, giving here is not just any 2 points. Well, these 2 points have something in common. And what is common to the points is the same vertical position. So if they are at the same vertical position, they could be placed over same horizontal line, right? Here is 3, -5, and somewhere over here should be the other point. But they are on the same vertical or horizontal line because they have the same vertical position. So to know whether a point is equidistant or has the same distance to these 2 points, do we really need the full position of the point? If we were to know the vertical position of this point, well, the vertical position actually indicates a full horizontal line as all the possible locations for a point with a given vertical position. And curiously, the first statement simply tells us that the point P is at the same vertical position as these 2 points. In other words, the point P could be virtually any possible point on this horizontal line that contains. Clearly, there is just one position over that horizontal line that would be fully equidistant at the same distance from both points, while all other positions wouldn't be equidistant from those points. So clearly, with this unique position, we would have a yes for an answer, while for any other, we would have a no. Clearly, this statement is not sufficient. Why? Because we simply don't know what is the horizontal position of the point. The x coordinate is unknown. So because of that, this is not sufficient. Now think about statement 2. Statement 2 says that the x coordinate horizontal position of point P is -1. Now think about these 2 points on the same vertical position. Imagine a point like this, okay? Imagine a point like this. Imagine P is over here. With that position, you clearly can tell whether the point is equidistant or no. Under all appearances, the point seems closer to the point in the leftmost position, -5, -5, and seems farther from the other one. Yeah, that's because here you can see the true position of the point. But what would it be like to just know the x coordinate of a point? It just means that the point is located over, one vertical line. And on that vertical line, the position of the point could be anything, because all those points on the same vertical line would have the same horizontal position. People, would that be enough? For example, if you just know what is the precise location of this virtual vertical line regarding the points we are measuring. Okay, or sorry, not this, but the ones in red. These two. If we were to know that the point P is on a given vertical line whose horizontal position is clearly known, would you be able to tell whether the point is equidistant? Yes, you could find the answer to the question. For example, say that this were, let's use another color, this were the vertical line containing point P. Okay, any point on that line, if the line is not equidistant from the 2 points we are measuring, obviously this point will not be equidistant. There is only one possibility that the point on a vertical line, on any position on a vertical line, would be equidistant from these 2 points. And what would that condition be? Well, if you consider that these 2 points are forming a horizontal line segment, there must exist a single line which crosses exactly through its midpoint. And any point, that's called a line bisector, right? A perpendicular line bisector for the segment with endpoints given in the question. So, if a point belongs to that perpendicular bisector, no matter in which vertical position is found, it will always have the same distance to the 2 points. But if the point is located anywhere else that is on a line that is not the perpendicular bisector, you also have the possibility to answer the question. The answer would be on the negative. If the point is located on the perpendicular bisector, there is a yes. If the point is not located on that perpendicular bisector, the answer is a no. So you have a definitive answer. Since you know the horizontal position of that vertical line, then you can tell yes or no. Now think about this. Is this horizontal position at the same distance from this and this? Well, it happens to be the case. Take a look. You have 3 here, you have -5 here, and you have a line crossing at point -1. What's the distance between these 2 points? 4 units. The distance between these 2 points, 4 units. So it just happens that point P is located, in a horizontal position such that it coincides with a perpendicular bisector of the line segment whose endpoints are the points in the question. Therefore, any point placed on that perpendicular bisector must be at the same distance from the endpoints of the line segment being crossed. In other words, the answer with statement 2 is a yes. And therefore, the correct answer to the question is option B. Okay, so that's how the property of the perpendicular bisector works in this kind of question.